Alright guys, I believe this is where we stopped yesterday. Okay. So we've done one example or two, a few example problems of adding and subtracting these rational expressions. And whenever we add or subtract rational expressions, we want the denominators to be the same. Because for us to be able to add or subtract, we need the denominators to be the exact same. So the first thing we need to do is factor the denominators as far as we possibly can so that we can see what we need to do, what we need to multiply both of the rational expressions by to get the denominators to be the exact same. Okay. I was doing this all last hour too. Yep. Okay. Dry skin. Sorry. Yeah, they'll crack and bleed like this every year. Gonna have to start using lotion way more often. Now, if we look at the first one, the 2x minus 2, we see that there is a greatest common factor of 2 between both terms that we can factor out. And if we factor a 2 out of 2x, we're just left with the x minus 2 factored out from 2 leaves us with 1. So we can factor 2 out of both of those terms. Now for the x squared minus 4x plus 3, well, there isn't a greatest common factor between these three terms, so we'll use our two sets of parentheses with 3 spaces. Now because the 3 is positive, the signs are the same and they're going to match the sign of the middle term, which is negative, so negative and negative. And the factors of x squared, our first term, are going to be x and x. And the factors of 3 are 3 and 1 or 1 and 3, because those are the only factors of 3. So this here, the x squared minus 4x plus 3 will factor to x minus 1 times x minus 3. Okay. Now we need to get the denominators to be the same. Now the way we can do that is multiplying the top and bottom of each of these expressions by a certain set of terms. Get the highlighter out. Now what we want to see first, what does x minus 1 times x minus 3 have that 2 times x minus 1 does not? X minus 3. So we can see that the 2 times x minus 1 does not have an x minus 3, because the other one does, yes? So if I want to get them to be the same, the 2 times x minus 1 needs what? The x minus 3. So on top and bottom, I'm going to multiply it by x minus 3 to get them to be the same. Is there anything else that the x minus 1 and x minus 3 have that the other side doesn't? No. Okay, so we're good there. All right. Now we're going to go the other direction. What does the 2 times x minus 1 have that the x minus 1 times x minus 3 doesn't? The 2. So I'm going to multiply it by 2 on top and bottom. Now the denominators is going to work out to be 2 times x minus 1 times x minus 3, because that's what's going to make them all be the same. So the least common multiple or least common denominator in this case is going to be 2 times x minus 1 times x minus 3. Now we can multiply the numerators, and we're going to have to multiply them out in both cases because we're going to have to subtract the like terms. So for the first one here, well, we'll distribute. We'll do x times x and x times 2. Well, x times x is x squared. X times 2 is going to be plus 2x. Now we can also do negative 3 times x, which is negative 3x. And negative 3 times 2 is negative 6. And that's all the distributive property for the first rational expression. Now for the second one, we're going to distribute and multiply through by 2. So 2 times negative 2x is negative 4x. 2 times negative 1 is negative 2, so we'd have minus 2. Any questions on how we got to this point here? Now, I hate doing this, but we'll do 2 steps kind of in one, because I don't like doing more than one step at once. Because I know that y'all are running a little bit short on room. Yes? About to run into the next problem on the page. So, we're going to go on and combine, so actually combine the numerators, subtract them, and combine like terms. Because if we look at the first one, well, we have x squared. Well, 2x minus 3x is negative x minus 6. So, okay, so we combine those like terms. Minus our negative 4x minus 2. Because for some of the other hours when we covered this problem yesterday, we rewrote it with combining like terms and then had another step for actually having them be subtracted. And this is all over 2 times x minus 1 times x minus 3. Now we can include the parentheses around the first one, but it's not too important because the sign for it's not going to change. The signs for the 4x, the negative 4x and negative 2 will, because we are doing what? We are subtracting them. So the x squared minus x minus 6 isn't going to change, but if I subtract a negative 4x, the negative and negative make a positive. So really what we have is plus 4x. And if we subtract the negative 2, the negative and negative make a positive 2. So now that we have the signs taken care of, the denominators are the same, and we have everything as a single rational expression, we can go on and combine the like terms on top. Well, x squared is by itself. The negative x plus 4x is going to be plus 3x. And negative 6 plus 2 is negative 4 over 2 times x minus 1 times x minus 3. Now, any questions on anything we've done so far? Can we factor the numerator? Most likely. two sets of parentheses. Now, since the 4 is negative, our signs are actually going to be the opposite. Factors of x squared are x and x. And what factors of 4 would we use? 1 and 4. 4 would be positive, and the 1 would be negative. And if we wanted to check this, we can, because x times negative 1 would be negative x. 4 times x is going to be plus 4x, which would give us a positive 3x for the middle term, which was what we wanted. Now, if it does factor, the numerator does factor, we will need to factor it. But incidentally, when we factor this, what do we get on top and bottom? Yeah. X minus 1, so these here will actually cancel out, leaving us with x plus 4 over 2 times x minus 3, which is the final answer. So a lot of these here, we do need to make sure that we check to see if the numerator will factor, because if it does, we need to factor it to see if there is anything in common on top and bottom. It's not always guaranteed that we will have something in common on top and bottom, but if we do, we have to simplify it out. So the final answer for this here is x plus 4 over 2 times x minus 3. Any questions on this here? These problems here do kind of get frustrating when you get all the way done and find out like the answer is 1. All right. Let's look at another one. 5x minus 1 over x squared minus 3x plus 2 minus negative 2x minus 1 over 2x minus 4. Well, the first thing that we'll need to do that's going to be helpful is to factor the denominators as far as we can, so we can see what we need to do to make them be the same. Which one do we want to factor first? Let's do this one here. Now, since the third term, the 2 is positive, the signs are the same and they match the sign of the middle term, which would be negative and negative. The factors of x squared, well, are just x and x, and the factors of 2 are 1 and 2. Now we also need to factor 2x minus 4. Well, there's no way we can rewrite it as 2 sets of parentheses with 3 spaces, mainly because the degree is 1. But there is a greatest common factor of 2, which we can factor out of both terms. And if we factor the 2 out, we're left with x minus 2. All right. So again, what is the x minus 1 times x minus 2 have that the 2 times x minus 2 does not? The x minus 1. So we can multiply top and bottom by x minus 1. Now what is the, and that's it, isn't it? But that's all that the x minus 1 times x minus 2 has that the 2 times x minus 2 doesn't? It's just the 1? Yeah. So let's go the other direction. What does 2 times x minus 2 have that the x minus 1 times x minus 2 doesn't? The 2. So we're going to multiply top and bottom by 2 over 2. So the least common multiple, or the least common denominator, in this case is going to be 2 times x minus 1 times x minus 2. So when we were talking about least common multiple yesterday, it's doing this exact same thing. Now, they reference it here as a least common denominator, because what are we trying to make the same in both equations? The denominator, the bottom of the fraction. So they call it a least common denominator. Now we do need to multiply the numerators by these terms. So on the left, we're going to multiply by 2. So 2 times 5x is 10x. 2 times negative 1 is negative 2. Now I did put the parentheses around that just as kind of a reminder for us that we are multiplying negative 2x minus 1 by x minus 1. So we'll need to distribute. Do our negative 2x times x, which is negative 2x squared. Negative 2x times negative 1 is going to be plus 2x. Then we'll do the same thing with negative 1. Our negative 1 times x is going to be negative x. And negative 1 times negative 1 is going to be plus 1. Any questions on how we got to this point here? Well, this one here we will need to combine our like terms. And we can do this in one step, because 10x minus 2, do we need to do anything with it? Any like terms combined? No. So we can leave it as 10x minus 2. We can put the parentheses around it. We don't necessarily need it because the sign in front of them, both terms, is not going to change. But we're subtracting from it what? This here. Well, the negative 2x squared is by itself. But we do have that the 2x minus x, those are like terms. What is 2x minus x? Just x plus x. Then we have plus 1. So any questions on this here? Are we comfortable with doing those two steps kind of in one? All right. Well, the 10x minus 2 isn't going to change, but because we're subtracting everything inside of this set of parentheses from the 10x minus 2, well, the signs are going to change. Because if I subtract a negative 2x squared, the negative and negative become positive. And if I subtract a positive x, well, it's going to look like a negative x. And if I subtract a positive 1, it's going to look like a minus 1. And this is still over 2 times x minus 1 times x minus 2. I forgot that parenthesis. So the last two things we need to do, one is we need to combine like terms in the numerator, then see if it's factorable and simplify where needed. Well, 2x squared is by itself. There's no other variable with an x squared. Now we do have negative x and 10x, which would give us plus 9x. And negative 2 minus 1 is negative 3. Over 2 times x minus 1 times x minus 2. Now, is there a greatest common factor between 2, 9, and negative 3? Yep, okay. What is our greatest common factor between the top three? No. And most likely, we're not going to be able to use the factors of 2 and factors of 3 to somehow manage to get to 9. It's just not going to work. So this here is our final answer. Any questions on this here? I found this kind of funny in the last hour, but we go from those big denominators to 4x and 7. Well, I'm going to rewrite it down here. Now, there's nothing really we can do with 4x or 7 to factor it any further than it already is. They're single terms, so we are really just going to leave them alone. So the first thing we're looking at is seeing, so we can go either direction, but we need to see what does 4x have that 7 doesn't. Well, the 4x, yes? So we know for certain I need to multiply this side by x and x, yes? And that would take care of all the variables on both sides, yes? Both denominators will have the same number of variables. Now we need to get 4 and 7 to be the same, yes? Now it could work out that we could say that this is 4 and 4, and this is 7 and 7. But we need to be careful with it just in case that's not the smallest number. And I could check that with saying 4, 8, 12, 16, 20, 24. That might be enough. And then we can go 7, 14, 21, 28. Then it would be 35, yes? Well, the next one for 4 would be. So 28 would be the first number where they're the same, yes? So what times 7 is 28? What times 4 is 28? Okay, so it did work out that these are actually the smallest numbers to use to actually get them to be the same. But if there was one smaller than either one of those, we'd want to use it. Now, would it hurt to have a bigger number used? Well, no. It just means at the end, when we simplify, there's a greatest common factor we'll have to pull out of the top and bottom, and it's going to be whatever that scale is. So let's go on and multiply these together. 7 times 3 is? Well, 7 times 4x is? Well, 28x. Minus 4x times 1 is? 4x. And 7 times 4x is? 28x. Well, we now have the denominators as the exact same thing, yes? So the denominator will be 28x. The numerator is going to be 21 minus 4x, because we can subtract those. Well, they're definitely not like terms. Is there anything in common with 21 and 4x that we can factor out? Well, no. So this here is actually, I simplified it as it gets. Now, we could write it as negative 4x plus 21 over 28x. We can write it as either way if we want to put the variable out front. Now, we're not too concerned. I wouldn't be too concerned with the 4x being negative. The only time we would really want to concern ourselves with a negative sign is if the denominator is negative. Then we'll want to move the negative out to the front or up top. Apply it to the numerator. But that's it. Any other questions on this here? How do we feel with addition and subtraction with these rational expressions? Not too bad. A little bit, think a little bit better of them than we did yesterday. Still rather multiply or divide. Let's do one more. I'll let y'all pick out of the last, I think, 3 remaining, which one y'all want to look at. I have a feeling I know which one. This one? Okay. I'm going to try to do this one correctly this hour. And it's not that I didn't do it correctly last hour. For some reason, I decided to take this negative and make it a plus on the first step and worked it all the way through. So it doesn't really change anything. It just changes what the answer will look like. The process doesn't change. So they still cover the same process, just kind of got to a different answer. Now, what we're going to want to do first is just get the 3 denominators to be the same, yes? And we're going to do that by, well, factoring each of the denominators and then multiplying each one by the terms that we need to get them to be the same, yes? Well, the reason I point that out is I'm going to need to leave, because we'll need to leave a little bit of space for the first one so we can multiply, yes? Well, now that we actually have a middle one, it might be helpful to leave a little bit of space in the middle so that we can multiply for the middle term. And I about wrote a minus again, or changed it to plus again. I have a 4x here. Okay. And let's fix that. Hopefully it's not too... There we go. And that actually might get it to work well. So, for this here, like the ones before, the numerators are not going to change. And thank you for that catch. Now, we need to factor any of the denominators that we can. Well, there's 2 of them that won't do anything too. We can't change anything about. That would be the, well, x minus 4 and x. Because both of those have a degree of 1. The x minus 4, there's not a greatest common factor between x and 4. And, well, x is by itself. But we can factor the x squared minus 16. And how would that factor? X plus 4 and x minus 4. Because it's kind of nice, it's the difference of perfect squares, which will factor in this way. Okay. A highlighter. So we can look at the x plus or x minus 4 first. It doesn't matter which one we look at first, we just need to pick one and do it with the other 2. So what does the middle one, x, have that x minus 4 doesn't? Well, that would be x. Because it has an x by itself, the x minus 4, because that's one term, it doesn't have an x. Okay. Now we can also look at the last one. What does x plus 4 times x minus 4 have that the x minus 4 doesn't? X plus 4. So now, in that first one, when we multiply those together, we do have a single x by itself, yes? We have an x minus 4 once and an x plus 4 once, yes? And in all the other ones, the middle one we do have the single x. Okay, we're good there. And the last one, it has 1x plus 4 and it has 1x minus 4. So does the first one have all of those? Well, yeah. Okay, let's look at the middle one. So it has just an x, yes? So what does the x minus 4 have that the x doesn't? Well, x minus 4. Okay, well that takes care of everything because we're not looking at what we're multiplying with it by yet. And lastly, we can see what does the x plus 4 times x minus 4 have that the x doesn't? X plus 4, yes? Do I need the x minus 4 from this one here? Well, what have I already applied to it? 1x minus 4. And out of any of the three, how many times does x minus 4 appear? Once. Since it only appears once in all three denominators, not what we've written in green, I only need it once. If any of these that I have in highlighter, so the purple highlighter, the blue, or the green, if I had it in any of those twice, I would need it in all of them twice. So here, we only need it once. We only need the x plus 4 once because it only appears in each one of them once. And since we just have an x to the first, we only need one x in all three of them. Lastly, what is the x plus 4 times x minus, or what is, so here, what does our x minus 4 have that the x plus 4 times x minus 4 doesn't? Well, at this point, nothing, right? Because the only thing it's missing is the x. So here we're going to multiply it by x over x. All right. Now, we're going to be multiplying these together. And luckily for us, the denominator is just going to be x times x plus 4 times x minus 4. And probably by the end of this problem, you'll be tired of writing x times x plus 4 times x minus 4. Maybe for some of y'all, you were already tired of writing it before we even started. Now the numerators we're going to need to multiply together. Now out of the three of these, one of these is actually really easy to multiply. That would be the one on the far right, because we do 4x times x, which is 4x squared, which isn't too bad. We can do the middle one next. So 2 times, well, we have our 4x, x minus 4 times x plus 4, yes? What happens when we multiply those together? What do we get? X squared what? Minus? Well, the reason we can do that quite easily is, well, where did we get the x minus 4 and x plus 4 from? Our x squared minus 16, that's what the factors of it are, yes? Well, if it already gave it to us, might as well just put it back into the original form if we're multiplying. So we can kind of jump from x minus 4 times x plus 4 back to x squared minus 16. Now, well, in the front we have x times x plus 4 times x minus 2. We actually have to multiply these out. Now we could do the x plus 4 times x minus 2 first, and then multiply it with the x, or multiply the x through first. We can go on and just distribute the x through the x plus 4. Well, x times x is plus x times 4 is 4x. Well, our denominators are all going to be the same. Now for our first numerator, we're going to go on and do our distributive property. So we multiply through with the x squared times x would be x cubed. X squared times negative 2 would be negative 2x squared. 4x times, then we'll do the same with the 4x. Well, 4x times x is going to be plus 4x squared, and 4x times negative 2 will be negative x squared, or negative x. Then for the middle, we're going to distribute the 2. So 2 times x squared is going to be 2x squared. And 2 times negative 16 is going to be negative 32. And the last one's still going to be 4x squared. Any questions on this here? Okay. Well, if we feel comfortable, we can go on and put these all in the same one and combine like terms at the same time for each individual one, not for the whole thing. So for the first one, we still have our x cubed, but we do have a greatest common factor between these two of negative, because we have negative 2x squared plus 4x squared, which is going to be plus 2x squared minus 8x. Plus our middle one is 2x squared minus 32 minus 4x squared. All over x times x plus 4 times x minus 4. Well, the only thing we need to do now is combine like terms and see if we can simplify anything. Well, looking at the numerator, x cubed is its only like term. Well, 2x squared plus 2x squared minus 4x squared is 0. Then we have negative 8x minus 32 over x times x plus 4 times x minus 4. And that there is going to be as simplified as it gets, because there is no greatest common factor between the top three terms. Now, if it had been plus, if we had had a plus 4x squared, we could have factored by grouping to been able to simplify down. But this is as simplified as it gets. Any other questions on any of this here? And that is it for today's lesson. So 4 through 6, 8, 12 through 14, 20 through 23, and 26.